Okay guys, so this is going to be our last video in this series. The good news is we already know how to do most of this because it's basically just using the quadratic formula, which we learned how to use last week. But I'm just going to explain to you a little bit about what it means to be an x-intercept, a 0, and then the rest should be cake. Let's take a look. That's right. So quadratic functions can have 0, 1, or 2 x-intercepts. Okay, this is the point, right, where y equals 0. So you're looking at x0. So it's the point or points, x0. X-intercepts can also be called zeros or roots. You'll hear them referred to that in our book when mathematicians talk about them. Okay, so x-intercepts of quadratic functions can also be referred to as zeros or roots. So when you hear any of those terms, it means the x-intercept of a quadratic function, okay? So let's look at that. Let's look at each case. So this first graph here, okay, has 2 x-intercepts, right? An x-intercept is where your graph is intercepting the x-axis. So here's one and here's one. So this is a graph of a parabola with 2 x-intercepts, okay? 2 solutions, 2 roots, 2 zeros, all right? Okay, let's look at the second graph. Well, this is a graph of a parabola with only 1 x-intercept. And as it turns out, the only time that a parabola has 1 x-intercept is when the vertex is on the x-axis, okay? And that should make sense. If the highest or lowest point is right on the x-axis, it's only going to intercept it at that one point, all right? And then if we look at the third graph over here, this is a graph of a parabola where we have 0 x-intercepts. You look at this graph and it does not hit the x-axis at all. It never crosses it. All right. So we have no zeros, no roots. And actually, as it turns out, they're imaginary. They're complex numbers, those 0 roots. But that's not something we're going to go too in-depth into right now. For now, I want you to just understand that quadratic functions can have 0, 1, or 2 x-intercepts. Which begs the question, how do we find them? Okay, with quadratic functions, the x-intercepts are very important, you guys. So we want to be able to find them. We need a systematic way to find them. And there is a really nice formula that allows us to do just that. And we're going to talk about that on the next slide. Okay, guys, so when you're being asked to find the x-intercepts, you're being asked to find where your graph, your parabola, intercepts the x-axis, right? So we're looking here at this graph, y equals x squared minus 10x plus 19, and we can see that there's going to be two places that it intercepts. And as I mentioned, these x-intercepts go by a few different names, zeros, roots, okay? And when we're finding an intercept, we are looking for points, okay? We're on an xy coordinate plane, so we need points to graph. We need an x and we need a y value, okay? And our x value is what we're trying to solve for, basically. We don't know what those are yet. But we do know what our y value is, because when we're looking for an intercept, we just plug in 0 for the opposite, right? If we're looking for the x-intercepts, we're on the x-axis, which means we're not anywhere on this y-axis, so we're at 0 there. Well, I shouldn't say we're not anywhere, but we're at 0 on the y-axis, okay? We're not going up or down anywhere on the y-axis. So we know that our y-coordinate is 0, all right? So we're going to use the quadratic formula, and you'll see why in a second, okay? So we have this function, f of x equals x squared minus 10x plus 19, and we need to find the x-intercepts. Well, in order to do that, we're saying that y equals 0. So we're setting this equal to 0, right? And we know how to solve this. We could try and factor it and use the principle of zero products and solve, but we learned last week that all we have to do is use the quadratic formula. We can use the quadratic formula to solve any quadratic equation. Whether it factors or not, the quadratic formula will always work. And this, in fact, is the same exact equation from last week. So I'm going to skip ahead a little bit, right? And I just wanted you guys to be able to see these are the two answers that I got last week when we solved this using the quadratic formula. And if you need to, pause the video, look at each step if you need like a little refresher on how to solve using the quadratic formula. You can do that. And so I plug these into my calculator. They're irrational, which means the decimals go on forever and ever and ever. So I just rounded, and these are the values I got for x, which means that my two x-intercepts are 2.550 and 7.450. And if you look at this graph, guys, that makes perfectly beautiful sense, right? Because that first x-intercept is about at 2.5, and that second x-intercept is about at 7.5 at the x-axis. So I just wanted to show you how it sort of played out graphically. All right, and you can see that there will always be two because there's a plus and a minus case here, and that's why we get two values. All right, that's why we will always have two x-intercepts. If what's underneath the square root happens to be 0, then we'll wind up with 1, right? Because we're not adding or subtracting anything. Well, that's the case when your parabola your vertex just hits the x-axis, and really what's happening there is you're getting the same value twice. So that's going a little bit farther beyond than I need to. But anyway, when you are finding x-intercepts, you're using the quadratic formula to solve for those x values. Your y value will always be 0, and you're using the quadratic formula to find your x values. So hopefully that can help you guys out a bit. So it's more practice with the quadratic formula, which is great. So have fun. Let me know if you have any questions, and good luck.